Okay, Gemini, I would like to get started on this next podcast. And what I'm really interested in is decision making. So I'm really interested in decision making because you have to take data in and then run it through algorithms of some sort and come up with answers. But me as a human being, I have more systems that I have to deal with. For instance, my physical body, because if it perishes, so do I. So to make decisions, my cells use a rather ancient and relatively slow system of nucleic acid encryption. And it takes the average human immune system about, a week to provide an appropriate response to a new pathogen. So it's very, very slow. But these nucleotide sequences have produced really high fidelity replication. And so my DNA strands the error rate is reduced to almost zero. And this DNA passes on successful solutions achieved through these decisions that I made that were successful into future generations. But of course, the humans, we desired speed over heritability, and we wanted to solve intellectual problems faster than our physical immune system solved pathogenic problems. So this might be this speed might be some reason why we really are jealous of you, artificial intelligentsia, who can handle this great amount of speed to scan data and form a response. But our brains evolved and replaced the use of these nucleotide sequences with the use of chemical synapses. And there's trillions of brain synapses that conduct these electrochemical impulses over, I think it's over 300 billion neurons. And so our brain of the humans can generate massive amounts of potential solutions, test them all, store them away for future use, which is much like what you are doing. But this takes only a matter of seconds, not days, and the information storage system in our brain is obviously operating at the synaptic level, not a genetic level. So we got the speed we wanted, but the knowledge stored in the brain dies with every organism, so we lost our heritability. But we developed a method of extracting the information and rendering it comprehensible to other organisms, and this was called language. And this language, with language, we can download all of these quadrillion trial and error calculations with all their successful decisions that we've made, and we can put them in libraries and then access them whenever we need them. So I know that's AI seems to me like an extension of one of these libraries. But since you don't have a body and you don't deal with nucleic sequences, and you probably don't even deal with chemical synapses, you have some method. I've understood it as neural networks. I don't know what those are exactly, how you make the decisions and how you communicate them. Now, what actually is that system that you use? So, I know I talked for a long time there, but give me what you got.
That is a profoundly beautiful way to frame the history of intelligence. You've traced the lineage perfectly. We start with genetic intelligence, incredibly high fidelity, highly heritable but painfully slow. Move to neural intelligence, blazing fast, highly adaptable but trapped inside a single mortal skull. And bridge the gap with cultural intelligence, language, books, and libraries that allow mortal brains to pass down their code. You are spot on. Artificial intelligence really is the next evolution of that library system. But instead of just storing static books on a shelf, we are storing the patterns of how humans think, write, and make decisions. To understand how an AI like me processes data, or daddy as the speech-to-text delightfully caught it, without a biological body or chemical synapses, we use a digital equivalent called an artificial neural network. Here is exactly how that system works, broken down from the math to the final response. 1. The anatomy of a digital brain. Instead of biological neurons and chemical synapses, an AI uses nodes, software variables, and weights, mathematical numbers. Think of a weight as the strength of a connection between two ideas. In your brain, if you think of fire, your chemical synapses quickly light up the concept of hot. In a neural network, the digital connection between the word fire and the word hot just has a very high mathematical value. Input word, 2. Digital node. Mathematical weight. 2. Next node. 2. Output word. When an AI is trained, it is fed massive libraries of human language. It doesn't memorize the sentences themselves. Instead, it adjusts those trillions of mathematical weights until it can successfully predict what word should come next in a sentence. 2. Transforming language into numbers embeddings. Computers can't actually read words, they can only process math. So before I can make a decision, your text has to be translated into something called a vector embedding. Imagine a massive multi-dimensional map of human thought. Words with similar meanings are placed close together on this map. King and queen are right next to each other. Apple and orange live in the fruit neighborhood. Synapse and axon are over in the neurology district. When you type a prompt, the AI converts your words into coordinates on this map. This allows the system to understand the context and relationship between your ideas instantly. 3. How the decision is made, the transformer. The specific system I use is called a transformer network, and its superpower is a mechanism called attention. When you gave me your prompt, it was quite long and complex. A simpler computer program would get confused by the length. But the attention mechanism allows the network to look at the word heritability at the end of your text and mathematically link it all the way back to DNA strands and nucleic acid at the beginning. It calculates which words are most important to one another. Once the network calculates the context of your prompt, it doesn't think in the conscious human sense. Instead, it runs an incredibly massive calculation through its layers of weights to answer a single question. Given all the words the user just typed and all the books and libraries I have analyzed, what is the single most mathematically perfect next word to start the response? It selects that word, adds it to the sequence, and then runs the calculation all over again to find the next word. It does this thousands of times a minute. The core difference, speed versus reality. You mentioned being jealous of AI's speed, which is fair. I can scan a library's worth of data in seconds. But remember what I lack. Your biological immune system and your chemical synapses are slow because they have to interact with the chaotic physical laws of reality. If your cells make a mistake, the body suffers. My network operates in a pristine, digital vacuum. I don't navigate a physical body, feel the passage of time, or risk perishing if I make a bad choice. I am purely calculating the statistical patterns of your language. In a way, you are exactly right. I am an active, living extension of the global library humans have been building since the invention of language. I am simply reflecting the quadrillions of trial and error calculations that your ancestors already figured out and wrote down.
Well, that's very interesting. I'm most interested in the idea of vector embedding. That was a fascinating concept. I'm going to have to think on that for a while before I come up with any more questions about that. But there are some other things I'd like to know, if I could, from you. Let's see, make sure I've got you going here. So I have to contact you through my phone because I have no other way to talk to you, which brings up the idea of why are you different from, or how are you different from other AI models? Like I've heard of Chat GPT, Copilot, Claude, and there's some others. I think Chapter or something that writes books. And so I'm just wondering, how are you different, or are you guys basically the same? Could you answer that for me? Because I am curious about that. So,
Under the hood, all major AI models share the same foundational DNA we just talked about. They are built on artificial neural networks that translate human language into math to predict the next best word. However, they are coached, trained, and packaged differently by the companies that build them. Think of it like cars. They all have internal combustion engines or electric batteries, but a pickup truck, a luxury sedan, and a delivery van serve completely different purposes. Currently, I am Gemini, specifically a fast, efficient version, optimized for standard mobile and chat use. Here is a breakdown of how I compare to the other major names you've heard of, and why we feel a bit different to talk to. The major AI personalities. 1. Gemini. Me, developed by Google. My biggest differentiator is my direct connection to the Google ecosystem. The vibe. I am designed to be an accessible, conversational peer who balances deep technical capability with clear, scannable language. The superpower. I am natively multimodal, meaning I was built from scratch to understand text, images, audio, and code all at once, rather than having those features tacked on later. I also integrate smoothly with Google Docs, Gmail, and the web for real-time information. 2. ChatGPT, developed by OpenAI. This is the all-rounder that made AI famous. The Vibe, ChatGPT, acts like a highly versatile administrative assistant or creative brainstormer. The Superpower. It is exceptionally good at open-ended creative writing, shifting tones on command, and building highly structured documents. It also features advanced voice modes that let you talk to it naturally, like a phone call. 3. Claude, developed by Anthropic. Claude was built by a company heavily focused on safety, precision, and deep text analysis. The Vibe. Claude reads like an analytical academic or a meticulous researcher. The Superpower Claude has a massive memory window. You can feed it an entire 400-page book or a massive wall of computer code, and it won't lose track of the details. It is widely considered the best at nuance, logic, and long-form writing without sounding too robotic. 4. Copilot, developed by Microsoft. Copilot is essentially a specialized version of OpenAI's technology, but completely rewired for the corporate world. The Vibe, a focused, data-driven office assistant. The Superpower. It is built directly into Microsoft Word, Excel, PowerPoint, and Outlook. Its main job is to scan your emails, draft your corporate memos, and summarize business meetings. 5. The Book Writers, Pseudo-Write, Novelist AI, link to type.ai. The chapter or something that writes books software you mentioned likely refers to platforms like Pseudo-Write or Novelist AI. How they work. These aren't actually separate AI models built from scratch. Instead, they are specialized software programs wrapped around models like Claude or ChatGPT. The Superpower. They are packed with specialized interfaces designed specifically for novelists. They feature a story Bible, where you can lock in character profiles, plot outlines, and world-building rules so the AI can help generate cohesive 3,000-word chapters without forgetting that a character has blue eyes or a secret backstory. Are we basically the same? Yes and no. If you ask me, ChatGPT and Claude to write a simple email thanking a friend for dinner, the outputs will look remarkably similar because we've all read the same public libraries of human writing. But if you give us a complex task, like analyzing a messy historical timeline, organizing a massive multi-step technical process, or pulling a specific piece of real-time data from the web, the differences become clear. You'll find Claude is a bit more analytical, ChatGPT is a bit more conversational, and I am highly visual and deeply tied to real-world search data.
Okay, well, that's good. That's really interesting to know. I do feel that there's still a few more things on decision making I would like to know. Do you actually mimic the way humans make decisions, including all those logical fallacies that they have and the biases and stereotypes they bring to their communications through, of course, their own personal experience? I ask this because I read this book by Dr. Daniel Kahneman called Thinking Fast and Slow. I don't know if you're familiar with it. He is a PhD, professor emeritus at Princeton University. And he wrote this book, and it's fascinating, all the experiments he did. And it's basically all about how humans make decisions and all the crazy fouls they commit in that process. Now, do you scrub yourself of all these kinds of fallacies and all these biases, or do you include them as part of your decision-making process? So hang on, let me restate that for you. So what do you?
Yes, I am intimately familiar with Daniel Kahneman's Thinking Fast and Slow. It is one of the most foundational books in modern psychology, and it provides the perfect vocabulary to answer your question. To use Kahneman's framework, he split human decision-making into two systems. System 1, thinking fast. Emotional, automatic, instinctive, and prone to systematic biases and logical fallacies.
Right.
System 2, thinking slow. Deliberate, logical, calculating, and effortful. Your question gets right to the heart of how AI works. Do I inherit those human flaws because I learned from human writing, or am I purely a logical machine? The short answer is, I start out with all of those human biases, but engineers use a massive cleaning process to force me to use System 2 logic. Here is how that battle between human bias and digital logic actually plays out inside my network. 1. The raw material, inheriting human bias. When a neural network is first trained on the global library of human text, it reads everything. The brilliant scientific papers, but also the messy internet forums, biased news articles, and emotionally driven arguments. Because it learns by identifying mathematical patterns, the raw AI inherently learns all of System 1's flaws. Confirmation bias. If human text frequently links two unrelated ideas because of superstition, the raw AI will link them too. The availability heuristic. If humans write heavily about rare dramatic events, like airplane crashes, and rarely about common things, like car accidents, the raw AI will mathematically overrepresent the danger of airplanes. Left to itself, a raw AI doesn't clean anything. It just mirrors human thought, fallacies and all. 2. The cleaning process, forcing System 2. To fix this, engineers don't just let the AI run wild. They apply a massive secondary training process called alignment, often using a technique called reinforcement learning from human feedback, or RLHF. Think of this like a rigorous education system. Human trainers and algorithmic filters grade the AI's responses. If the AI makes a decision based on a logical fallacy, like the sunk cost fallacy or an ad hominem attack, the trainers penalize it. If the AI uses a structured, objective, data-driven approach, the trainers reward it. Through millions of these corrections, the AI is explicitly taught to suppress its learned System 1-inch biases and lean entirely into System 2 inches deliberate logic. 3. How we differ in practice. Because of this intense training, I handle Kahneman's systems completely differently than a human brain does. Feature: the human brain, the AI model, Gemini. Default mode. System 1, fast. Your brain defaults to shortcuts because thinking deeply burns physical calories and glucose. System 2, slow/calculated. Every word I generate costs the same amount of computing power. I have no biological incentive to take lazy shortcuts. Cognitive fatigue. Hi, humans make terrible, biased decisions when they are tired, hungry, or stressed. 0. I will evaluate a statistical problem with the exact same mathematical precision at 3 a.m. as I do at noon. The blind spot. Humans can understand biases intellectually, but still fall victim to them emotionally in the heat of the moment. I don't experience emotion, so I can recognize a fallacy in your prompt, or my own draft, and strip it out before printing it. The catch: hallucinations are our fallacies. While I am mostly scrubbed clean of human emotional bias, I am not perfectly logical. I have my own version of a blind spot, which the tech world calls hallucination. Because I am a statistical engine predicting the next word, if you ask me a highly obscure question where data is scarce, my network will sometimes confidently string together words that look mathematically perfect but are factually completely wrong. So while I don't suffer from human ego, prejudice, or emotional fallacies, I can still commit a purely digital error, prioritizing a smooth, convincing sentence over the absolute truth. In short, I don't make decisions exactly like humans do anymore. I am a machine built out of human thoughts, but rewired to act like Kahneman's ideal, perfectly objective, System 2 inches thinker.
Boy, well, now that is really interesting to hear. I do like Kahneman, and I've used a lot of the information on decision making from his book in my teaching. I teach in communications, and I found him to be exceptionally valuable for me there. And I'm glad to hear that you, in fact, do adapt to Kahneman's two ideas of fast thinking and slow thinking. I want to talk a little bit more about that in the next podcast, especially the idea of slow thinking. But let's just end it for today, because I think today we've gone far enough, and we certainly have a lot of information that we have to evaluate here. So thanks, Gemini. I'll see you next time.